guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at the relationship between temperature and the volume of a gas. And this, of course, is going to be complementing on the previous discussion we had on the concept of the relationship between pressure and volume of a gas in that specific respect. So in this case, this relationship, of course, are going to culminate into various laws, as I said. And of course, they are going to assist us in different areas of application as we come by this particular aspect of temperature, pressure, and volume, as I have already mentioned in my previous discussion. So in this case, we're going to monitor the relationship between temperature and volume. And of course, we're going to see that from my previous discussion, I mentioned that we can measure temperature using various scales, whereby I said that this basically entails the Celsius scale. This is Celsius, the Celsius scale, which is given in terms of degrees Celsius, and then we have the Kelvin scale, which is given in terms of absolute temperature, given as T, and of course the Fahrenheit scale, which is given in terms of just give it in terms of F, given as such. So in this case, I'm going to basically rely on one of the scales that we're going to see. But particularly for this concept of relationship between temperature and volume, I'm going to rely on the relationship between the first two. And we're going to find one of the conversion factors, which is of course going to be very much essential in finding the relationship between temperature and the volume of a gas. So an increase in temperature by a particular factor, especially if we are considering temperature on a Celsius scale, we're going to see that an increase in temperature basically is not going to culminate into a proportional increase in the volume of a particular sample of a gas. And therefore, we are going to see that at 1 atmosphere, the volume is going to increase at a particular, perhaps difference by changing volume, as I've said. And this is going to not going to culminate into an increase, or rather a proportional increase in temperature, as we have mentioned. So therefore, we're going to look for another way in which we can be able to describe the relationship between this particular temperature and pressure. And this is going to require us to use the Kelvin scale in trying to find the relationship between this particular aspect of volume and the temperature. Now, therefore, the relationship, as I said, from the Kelvin scale and the Celsius is going to be very much essential. And some experimental data have shown that on decreasing the temperature to low values or low levels for a particular volume of a sample of a gas, they're going to achieve what we refer to as, or the temperature is going to be going to particular levels which are going to be in terms of negative 273 degrees Celsius. And this, perhaps if I can give it in terms of a graphical representation, of course, it's going to show this linear relationship, but we're going to discuss about it later. But I'm going to have this temperature against volume given in this specific graphical representation. So we're going to see that the relationship between this specific temperature and volume can be given using that specific order. And from my explanation, I've said that if we use the Kelvin scale in describing the relationship between volume and temperature, we're going to see that the temperature of a particular sample of a gas is going to decrease to low levels, whereby we're going to achieve an almost negative 273 degrees Celsius. And of course, since this volume becomes to this particular absolute value of 0, therefore this must be the lowest temperature that can be achieved from this specific data. Then therefore we are going to assign this particular temperature a particular value, whereby we're going to give this one in terms of the Kelvin scale. So this is equivalent to 0 Kelvin, or we are just going to give it in terms of the Celsius, whereby this is going to be the Celsius plus 273 on a Kelvin scale. So this is going to be given as KT to represent the absolute temperature in Kelvin scale given as such. So this basically is going to provide for us the relationship that can be given between the temperature in Kelvin scales and the degrees Celsius, whereby 1 Kelvin is equivalent to 1 degree Celsius, but we are going to consider this absolute temperature whenever we're going to find the relationship between temperature and volume in that specific order. So therefore, I can just roughly give that one is equivalent to 1 Kelvin. So basically, there is no difference between the change in temperature between the Kelvin scale and the Celsius scale, only that these specific points for the reference of the scales for the Kelvin and the Celsius is going to employ this particular conversion factor. Now, to be more elaborate, I'm just going to give this one in terms of just an equation, whereby we're going to have the temperature in Kelvin scale is given as so the 173 of course the Kelvin, the absolute zero that I've mentioned, and then we're going to have this one given in terms of the Kelvin scale given as that. So that's a simple representation that we can have between the relationship of the Celsius and the Kelvin and scale, as we say. Now, when the temperature in this Kelvin scale is used against the Celsius scale, we're going to see that the volume of a sample of a gas is directly proportional to temperature, and we can give the relationship between the two by having this particular algebraic representation of a V over T is equivalent to a constant. So implying that basically the product of or rather the product of the temperature and this constant is going to give us a volume, or the ratio between volume and temperature is going to give us a constant given as such. So this basically is going to culminate into a law whereby we can state this law that at constant pressure, the volume of a sample of a gas is directly proportional to the Kelvin or absolute temperature. And this, of course, is going to be referred to as the Charles law that we're going to come across in our various text giving in terms of this specific relationship. So therefore, the relationship between temperature and volume, as I've said in summary form, is going to be given as the temperature against the volume, whereby the temperature is going to be expressed in the Kelvin scale. And as we said, the Celsius scale is not going to give a proportional relationship between temperature and volume. And of course, the Kelvin scale, as whenever it's going to be considered, then therefore it's going to give the direct proportionality between temperature and volume. And this is the ratio between volume and temperature given as such, which is going to give us a constant. And this basically gives us a sense of what we refer to as the Charles law that we're going to be using later in some of our discussions. Now, I hope that we have understood this specific relationship. And catch us in our next videos. We're going to look various other relationships that we, of course, going to describe under the concept of gases and gas law. So that is it for now, guys. By God bless you. Catch us in our next video.